So 1.8 is never anybody's favorite section because it involves things that you have to memorize. All of the properties. Now, you have had 3 of the properties before in Math 47 if you took Math 47. So hopefully you'll remember them. So the commutative property basically says it doesn't matter what order you add or multiply numbers in. So A plus B is exactly the same as B plus A. And the same holds true for multiplication. A times B is exactly the same as B times A. It does not hold for subtraction or division because it does matter for those 2 operations what order those values are in. So a quick example would be 3 plus 4 is exactly the same as 4 plus 3, and you know that that's true. Or 8 times 9 is exactly the same as 9 times 8. The root word of commutative is commute. Think of what it means to commute. It means to move back and forth. If you commute to school, you go there and you come back. It changes order. So commutative property changes the order. Associative property says it doesn't matter how things are being grouped when you are adding or multiplying. So in other words, if you look at this side of the equal sign, the B and the C are being grouped together. Here, the A and the B are being grouped together. It doesn't matter. You're going to end up with the same answer in the end. Notice no order has changed, so there's no commutativity happening here. It's just things have been regrouped, and that's the same thing for multiplication. So just a really quick example would be if I had 2 plus 3 plus 8, that would be exactly the same as 2 plus 3 plus 8. Look, here, order of operations would say that I would have to add the 3 and the 8 first because they're in parentheses. So 3 plus 8 is 11, plus 2 is 13. Well, if I go to the right-hand side and do the 2 plus 3 first, 2 plus 3 is 5, plus 8 is also 13. So it doesn't matter how you group the numbers, and that's true for multiplication as well. Distributive property you've had. This is probably the one that you use the most often. Do you remember when you have the distributive property? If you're multiplying a value or a letter by something in parentheses, a binomial or a trinomial or one type of those polynomials, the A has to be distributed through. So you have to multiply A times B plus A times C. The A has to be multiplied by both. So we call that distributive of multiplication over addition because you go over the addition. But there's also one for multiplication over subtraction. If these 2 things are being subtracted in there, oopsie daisy. Let me rewrite that. I can't talk and write at the same time. There we go. This would be A times B minus, and then A times C. Those you've had before. So identities for addition and multiplication. So the identity for addition says if I take any number and if I add 0 to it, I'm going to get that exact same number back. So 0 is called the identity element for addition because that is the number that if I add it to something, I don't change its identity. It stays exactly the same. For multiplication, that identity element is 1 because if I take any number B and if I multiply it by 1, what do I get back? I get the exact same thing. Multiplying something by 1, whether it's a variable or a number, doesn't change its identity. So the identity element for addition is 0 and the identity element for multiplication is 1. And think about it as when you add by add 0 or multiply by 1, you don't change its identity. It stays the same. And finally, inverses. So we've actually already talked about additive inverse. Remember, additive inverse says if I take A and if I add negative A, I'm going to get 0. Remember, that's the same as opposites. So if I take A and add the opposite, I get 0, which, by the way, is the identity element. For multiplication, if I take any, let's use B, any value B, and if I multiply it by 1 over B, now that's not the opposite. Do you remember the word we had for that back in other math classes? The reciprocal. So if I multiply B, any number, by its reciprocal, I'm always going to get 1. So that's what the multiplication inverse means. Notice in both, I get the identities on the other hand side of the equal sign. So, simplify using the appropriate properties. So, we're actually going to use 2 properties to simplify this. What we're going to do is we are going to flip-flop the x and the -3 first. Now, when I did that, I just used my commutative property because I changed their order. Why I did that is to get my numbers together in a row. They weren't together in a row up here. They are together in a row now. Because now what I want to do is I want to regroup so that my numbers are literally together in a set of parentheses. So when I just went from here to here, can everybody see where I used my associative property? Because I changed what's in the parentheses, I have regrouped them. And I have regrouped them because now I can go ahead and I can add -3 plus 17, and I can get 14. And I have now simplified that expression. So once again, I did commutative property to switch these so that the numbers were kind of together, at least in a row. I then used my associative property to regroup so that my numbers were literally together so that I could then combine them by addition. Let's look at this. So I want to simplify this. Well, here, notice how my numbers are in a row, but I'm going to regroup and put the numbers literally together, like I did over here. So I've just used my associative property. I've regrouped because now I can multiply and get my simplified expression of 20x. My next 3 involve distribution, because notice I'm taking a -3 and I'm multiplying it by a quantity that's being either added or subtracted inside the parentheses. So I have to distribute. So I have to multiply, first of all, -3 times 2 plus, and then I have to multiply -3 times 7x. So the -3 gets distributed to both of them. And what is -3 times 2? That's going to be -6 plus -3 times 7x is going to be -21x. I just realized I have A, B, C, B, C. Well, that's nice. It's nice to know that your math instructor knows her alphabet there. So this would be D, if you care. So we have to think about this. What's really in front of this parentheses? This is really a -1 out there. And that -1 has to be distributed. So we have to multiply -1 times 8. That's -8. Plus, and then we have to multiply -1 times A, and that's -A. Minus, and then we have to multiply -1 times B to get -B. Now, having done that, I'm going to erase that. Hopefully you're using a pencil. Because what you want to start doing at this point, you would get the same answer, by the way, if you did that. What you want to start doing at some point, and I teach this to my 47 students, is you want to start thinking of the sign in front of the number or the value as the sign. So in other words, you want to think of this as a positive A. You want to think of this as a negative B. So watch how that translates into doing this problem. Well, -1 times 8 is still -8. Now, don't put a symbol here. -1 times A is negative A. And -1 times negative B, that's two negatives. That's going to be positive B. And there we have that simplified. So see if you can start thinking that way. All right, let's go over here. Now again, we have some distribution to do. So 9 times 2x is going to be 18x. 9 times +4 is +36. Do I distribute this 9 to this 9? No, because it's not in parentheses, so we just trail it along. Now, even though we haven't, and I'm using air quotes, discussed like terms, which we will in the next chapter, hopefully you see that I can combine these two numbers here. 18x, and if I have 36 plus 9, I'm going to get a +45. I cannot combine these two because this has an x and this doesn't. I'm not just adding numbers, and that has to do with like terms, which we are going to talk about in chapter 2. Okay, name that property. So you have to look at these problems and figure out what property from above, A through E, is being illustrated. So if we look at 2A, it says that a number added to its opposite is equal to 0. Well, hopefully you can see that that is the same thing as this property, which if you go back, you can see that that is property E, or it's the inverse property. Because when I add two additive inverses or opposites, I get 0. What I would do, by the way, is I would turn me off and I would do all of these and then come back and see how you did. Okay, so if we're looking at B, what's changed from the left to the right? Well, the first thing I notice, hopefully you do, is that the order has not changed. We have a -4, 6, an x, a -4, 6, an x. So it can't be commutative. What's happening going from the left-hand side to the right-hand side? Do you see that things have been regrouped? Here the 6 is grouped with the x. Here the 6 is grouped with the -4. This is the associative property. Things have been regrouped. All right, let's look at C, but let's really analyze C. Let's analyze it just the same way I just did B. Has the order changed? Yes, it has. Look, this Z plus 2 has become 2 plus Z. So it is the commutative property. What's inside the parentheses hasn't changed. There's a Z and a 2 here, and there's a Z and a 2 there. So it's not associative. They haven't been regrouped. Order has changed. If I look at D, if I multiply 3 by its reciprocal, I'm going to get 1. Hopefully you can see that is, again, inverse, but this time it's multiplication as opposed to addition, which is what it was in 2A. And last but not least, what is this one? Well, if you just look at the left, you might think, hey, it's going to be distributive, right? Because you have a value and then you're multiplying it by a set of parentheses, but is it distributive? No, the 2 has not been multiplied by 3, so it's not distributive. What has actually happened going from left to right? Do you see where two things that are being multiplied the 2 and the set of parentheses, have flipped places. The order has changed. This is commutative. It's not associative. What's inside the parentheses hasn't changed. Things haven't been regrouped. Things have changed order. And we have finished chapter 1.